Good morning and welcome to today's TPC Training webinar on the hidden value of maintenance and measuring training effectiveness. We are scheduled for no more than about an hour on today's webinar. We want to be respectful of your time, but first a couple of housekeeping items. First of all, we know everyone's going to have questions and we're going to take time at the end of the presentation to answer those questions. So if you have questions, you'll see on the right-hand side of your GoToWebinar bar, there's a little question tab there. Just type your question in right there and we'll get it answered at the end of the presentation. Probably the most frequent question we get from people is, can I get a copy of this presentation? And the answer to that is absolutely yes. At the conclusion of today's broadcast, you'll get a follow-up email with a survey and a thank you. Please just respond to that email. Just hit reply, respond to that email that you would like a copy of the presentation, and I will send that out to you most quickly. We'll also have a copy of the broadcast up on our YouTube channel. So if you have to cut out early, or if someone in your facility or in your office wants to see the webinar and they didn't get a chance to view it, we'll have that available for you on our YouTube channel, hopefully by mid next week. Without further ado, though, I do want to turn it over to our presenter. His name is Curts Background, and he's going to lead us through today's webinar. Kurt?
Thank you, John, and thank you all of you for joining me today for today's webinar. And as John said, we'll be talking about the hidden value of maintenance and training effectiveness, which also includes troubleshooting, preventive maintenance programs, and a lot of this will be a hybrid of much of what we discuss in any of one of our courses. And so what I mean by that, well, let's get this out of the way here. So as John was saying before, this is kind of who we are. And so most of the training we do is instructor-led. We have a big online platform, and a lot of the things that we train will be referenced from our robust online program training. Also at the same time, with our staff of instructors, including myself, we can tailor our training for you if you need it. And even in my own very classrooms, this course specifically, I have enough material to work with to where I can customize on the fly, if you will, this class to whatever the needs of the students are in that room at that time. And so either one, we can do that in like our open seminars, or two, if you want to do like an on-site, we can customize it for you, this course for that purpose. Basically, the whole maintenance idea and, of course, troubleshooting. So as John's pointed out, my name is Curts Brizendine. My background is 10 years in the Navy. And so as you can see there, I was a weapon systems technician. My training involves everything to do with AC, DC, solid state technology, digital type stuff, communications gear, radar. And of course, my title was a fire controlman. Had nothing to do with putting out fires, but probably everything to do with starting fires. Our motto was to put ordnance on target on time. And so using the various weapon systems the Navy had, of course, to do that, which was supported by the electronics for the computer systems, electromechanics, motors to drive the system, of course, hydraulics, pneumatics, that kind of thing. And obviously the ballistics that was associated with that as well. And so I ended up getting out of the Navy because my son was born in 2007 and I got out in 2008. So that's why I chose my family over the military. When I got out of the Navy, I picked up a job quickly at Exelon Nuclear, where I was a maintenance and engineering instructor there. Pretty much doing what I'm doing now, except at the power plant, it was more along the lines of prepping maintenance teams for our outages. And so like the 5 or so months in between our outages, that's what my job was. I would make a training for them that was customized for their needs, and building mock-ups if necessary, and then conducting training accordingly. However, when I was there for about 2 years, and they made it clear that I wasn't going to get promoted without a college degree, so I went to college. And so I graduated from Northern Illinois University a few years ago. I studied engineering and Western history, as you can see there. I know it's kind of a strange combination, but the engineering, of course, is punctuating my my technical background, but my teaching aspiration, my primary area of expertise is classroom instruction and curriculum development. The whole Western history side of that is how to do the research associated with it, write with it, that kind of stuff. And so that's kind of my background in all this. And so what I bring to my company here at TPC is just that, my proclivity for classroom instruction and for content development. And so now today, what we want to get accomplished is, first and foremost, as far as your technicians occurred, I want to provide, and this course wants to provide an avenue to measure how effective your maintenance program is. And so some of the things that are associated with that would be not only just how often things are breaking or how often you have to replace something, but also kind of in the idea of what's energy efficient, and then how all the various small things of maintenance are associated with that. And one of the things that I like to do in all my classes is I like to boil things down to as simple as possible and to assign the value of why this is important. And so this leads us to the value of maintenance. And so why is maintenance important? Why is it more of an investment than it is a cost? Because one of the biggest things, especially I really learned it in engineering school, was doing the advanced math associated with time value of money. Understanding that a little bit of a large investment in the short term is an actual large payback in the long term, meaning that it's better to spend a large sum of money now that'll last you for 10, 20, 30 years than paying for a small sum of money that's only going to get you through the next 2 or 3 years. And a lot of maintenance programs, that's the mentality that's behind the maintenance, is to be able to accomplish just that. And so with this, as I mentioned earlier, is that I provide, there are so many examples I have available for me in this course that whatever is specific to the needs of the student, I can pull up those examples. And so as we go through the course, I'll kind of give you an idea what those examples are. And finally, of course, we don't want to forget about workplace safety. Yes, we talk a lot about electrical safety, mainly because if you look at the data from the Department of Labor, that's still one of the largest sources of mishaps and near miss is regards to electrical safety. But we also talk about other safety like fall protection and like respirator type stuff, just general safety. And so maintenance-like training, as I mentioned, is an investment. And so the idea is to have the maintenance be done in such a way to prevent it from breaking at a time that is extremely inconvenient, if you will, or in a time that will be very expensive. And so part of understanding how a maintenance program is set up is making sure that those who are maintaining the maintenance program and those who are using it understand what is expected and the purpose of that maintenance program. And in the end, what it boils down to is to overall save your company money and to allow your company to be more efficient in general. And so, here we go. And so one of the things we teach in our classes here is, of course, we talk about preventative maintenance. Now, we can do this from multiple perspectives. And so, yes, I can do this from the perspective of the technician. So this is what they mean in the maintenance program. This is what we want to accomplish. These are the things that should be part of it. Things like what safety is applicable, where to find where the risk assessments were done to determine that was an actual safety issue, what things are mitigated for the safety, techniques as far as how to take measurements on various things, or tips on known challenges that I've come across with just understanding how maintenance is done on that. And this is, of course, from the perspective of the technician. Now, we also have the ability to turn that from the perspective of the person who writes the maintenance program, or even from the perspective of management in general. One of the things that we have, like one of our instructors, his name is Brett Smith, this is what he does. He does lots of classroom instruction just on maintenance programs. And so we can shift this course too to talk about it from that perspective, like how important it is to maintain an asset list, make sure it's up to date, where to draw the line of what's an asset. Are we going to talk about a single light bulb, or are we going to be talking about a group of light bulbs as far as our asset? Or if we're talking about an HVAC system, we're talking about the package unit, the condensing unit, the heating unit. Is that all one, or is that multiple ones? And so that's kind of how that conversation can go. And then, of course, breaking down the frequency of the maintenance. And so all of this is boiling down to determining what is routine, and then of course having the idea to formulate and word your maintenance in a manner that it allows you to detect impending problems. And the challenge with that is you don't want to have a maintenance wording on your maintenance thing to be so broad that the technician doesn't know what you're doing, but at the same time, you don't want it to be so narrow to where it's like, place bolt in hole A, place bolt in hole B. That's a little bit too much. And so the challenge in writing a maintenance program is finding that balance between the two. And so predictive maintenance, the idea behind predictive maintenance is it boils down to things like vibration analysis and thermography. Those are the common things that are used for predictive maintenance. How it differs from preventative maintenance is that predictive maintenance is supposed to be non-intrusive. Basically, while the system is operating, you have a way to be able to measure how effectively it's working without having to shut it down. Now, that does not mean it replaces preventative maintenance, because in general, most preventative maintenance boils down to cleaning and inspecting whatever it is that you want maintenance to be done on. Predictive maintenance is what it sounds like. It's to see how well that machinery is working and to be able to use non-invasive techniques to be able to predict or to trend out when it's going to have a malfunction of any kind. And so then this all boils down to what's called a reliability-centered maintenance, which is a combination of the preventative maintenance, your routine cleaning and inspection, and then of course your predictive maintenance, where you do your vibration analysis, thermography, that kind of thing, with the idea of if it ain't broke, don't fix it. And so a good reliability-centered maintenance, how it differs from a scheduled routine maintenance is that allows you to use the thermography vibration analysis for you to schedule maintenance when it's convenient for you, because it'll allow you to predict, this looks like based on a trend over a couple of months that it's going to break again here in 2 months. So especially from a production point of view, it says, okay, this gives you the managers time to let's schedule a shutdown, so that way that is more convenient, rather than wait until something breaks and then you got to shut everything down, and now the technicians have to be forced to hurry through it to get it fixed as quickly as possible. And so the idea, like I said, with reliable-centered maintenance is to allow you to schedule when the maintenance is supposed to happen, specifically making corrective maintenance more be preventative maintenance. So that way there's flexibility with that as far as production management and process management. And so all preventive maintenance programs are made of 6 parts. And so first and foremost, one of the things you have to do is constitute what defines a responsible and qualified personnel. Now, the various codes out there generally agree that what makes a person qualified is that they have the necessary knowledge, skills, the applicable safety training, and of course, with electrical safety, what was recently added in 2018 70E was that they know how to do a risk assessment. And in many cases, keep in mind that by doing the risk assessment doesn't mean that they need to sit down, have a full-blown meeting, do all the math and the predictive algorithms that sometimes come with really. No, the risk assessment just says him or her and one other technician gets together and says, yes, this right here is this is a 480 volt panel. We have to secure it from this disconnect over here. We're going to hang a lockout tagout device, and I'm going to check it here to make sure it's de-energized. Hey, I need to make sure that the blades on the disconnector. It's a conversation. That's my point. That's how you do a risk assessment, with the idea of bringing to the front to everyone who is involved. Say, hey, these are the hazards that are associated with it, and this is what we're going to do to assess and mitigate the risks that are associated. And so next is, of course, you can see here, survey and analysis of electrical equipment. Basically what that means is like the labeling, like your arc flash analysis, how often the maintenance should be done, taking into account specifically the condition of maintenance. In other words, it provides a baseline when you're conducting your inspections, so what your technicians know what to look for. And then, of course, programmed routine inspections, how often to do them. What can we do what kind of tests that we can do that's both safe and effective. And the last one is important, because if you do too many tests over and over and over again, then that can lead to complacency. If you don't do enough tests, of course, then you don't know when something's going to happen. So like I said before, that is a balance of between too much and not enough. At the same time, you don't want to waste the time of your technicians on doing a lot of frivolous work when there's other things that can be where attention can be directed to. And so that's kind of the point of bullet point number 3 here. Next, of course, is accurate analysis of inspection and test reports, so that whatever those corrective measures are that you decide, what those corrective measures can be. Now, how you do this will be based off experience. And so this is where your emergency planning comes into it in case there's a catastrophic failure of some kind, or you have an unexpected shutdown due to, like, power outage or something. That's kind of what this is referring to here, is that you have a program in place for your technicians to address it. Now, yes, not all corrective measures, because that's what corrective means, is that it breaks. And no, not all the time can you predict a breaking, or it could have been something that there's some accident that had happened someplace that no one foresaw. Clearly, there's not always a way to be able to address that on paper, but at least provide a template and have a plan in place to address those situations. And of course, as I kind of alluded to earlier, the performance of necessary work, whether it be make sure it's not too broad, at the same time not being too specific. And of course, very important is keeping concise and complete records. And the purpose of this is so that you can see the trending of your maintenance. And if you keep good records, what that allows you to do is to once again be able to predict or to see what root causes are. Because in many cases, whenever you're doing corrective maintenance, especially if it's a type of corrective maintenance on something that's new or that's been rarely, if ever, done before, that it's sometimes very difficult from a troubleshooting point of view to figure out what exactly caused the issue to begin with. And so by maintaining records, this allows you to see, okay, under these conditions, I can see at these regular intervals or whenever something occurs that this is when I get the problem. And so this is where the importance of maintaining good maintenance records comes into play. And so as far as planning goes, what's really important, as I mentioned before, is compiling a list of all your equipment. Someplace, this is the most modern forms would be your computerized maintenance management systems, your CMMS. There should be a giant exhaustive list of every single piece of equipment that any one of your technicians will ever touch. This includes things like your tools, PPE. Those should also be on the list of what needs to be doing maintenance. Then, of course, with this maintenance, determining what is most critical, because then this will determine if in the event, of course, you have conflicts, what the technician needs to focus on first. Or from a management point of view, to allow you to say, okay, you know what? Yeah, I know I had you scheduled doing this, but this is more critical because if we don't get this fixed, it's going to affect everybody else. And then, of course, develop a system for keeping up with what needs to be done. And so, like I mentioned before, whether it be regularly scheduled, whether it be predictive, some type of system, so that way, at the very least, you can have enable your technicians to be somewhat autonomous because they can follow a pattern that was established by your program. And then lastly is, of course, it's the purpose of why TPC exists, is to be able to train your people for the work that needs to be done. And so when it comes to maintenance and troubleshooting, we try our best as a training program to address the market and the industry as broadly as we can. And so that's one of the reasons why we created this course, is to address that broad spectrum of stuff. Because almost everything in this course that we have, we pull from our classes that are very specific and specialized. For example, we have pumps information, and there includes how to rebuild a pump, the statuses of the various type of impellers. We go through, like I just taught this class this week, just this last week here, and I spent 4 hours talking about nothing but bearings and all the things that go with that. So and that's just because the students are interested in such things. Other things would include, like I talked a fair amount about hydraulics. And if you ever go through any one of these maintenance programs, I almost always talk about electricity, because it's just one of those type of things that as I mentioned before, can be one of the more dangerous things. And there's depending on your level of expertise, sometimes there's still a little bit of a learning curve associated with that. And so, as I mentioned, these things that we have in this general course are pulled from our myriad of specific courses that we have. And so another thing with this whole thing is, of course, developing a walkthrough inspection checklist. Now, this is from the perspective of facility maintenance, mainly because that's one of the common things that we cater our training to. And so on a lot of facility maintenance is that one of the common tasks assigned is, of course, a daily checklist, rounds, or whatever it is you want, what you want the technician to look for at the beginning of every one of their days or once a week, whatever it is that you have as your program. And so, and with this comes your checklist. So once again, to minimize the day-to-day hazards. A lot of times this is as simple as just walking through the various parts of your plant, allowing the technician to use all of their senses, rather than just seeing something, be able to hear it and be able to smell it. Because any one of us who are technicians, I mean, especially like one of the examples I like to use, when you're sitting in your car. Have you ever been driving down the road and you hear something in your car, or you might think it's your car, shut the radio off, and you kill the HVAC system on your car, like, listen, because you're just listening for that, something that might be just off. And many technicians, that's how they do things. They can hear that stuff. And so we referenced the NFPA 70B, but one thing I want to point out is that the NF 70B is one of many maintenance guidelines. And so what I mean by this is the NFPA 70B is general maintenance, but if you want to refer to like specific maintenance, like one of the things we talk about is how to maintain fire protection systems, that's NFPA series 13 and 25. So that's for installation, for the baseline, 25, how to do the maintenance. And then, of course, if you work at a data center, that's NFPA 75 and 76. And there's NFPA 110 for generators, et cetera, and so on. And so that's my point. The NFPA 70B is general, but don't forget the other specific ones that are pertinent to whatever it is you're doing maintenance on. And so this list is not complete, nor do the items necessarily appear to be in the order of importance. And that's the thing to keep in mind. It doesn't have to be. It's to make sure that that you check everything that needs to be checked. And a lot of times the way I've built programs in the past, especially when it comes to a checklist, it's more based on a physical route that the technician will take. Starting at their office and what route you have to take through the various hallways and the doors you got to go outside and stuff. That is the idea here. And so the list is designed to give a general overall view, a starting place, and an area to be able to identify if corrective maintenance is necessary before it becomes an emergency. And of course, this should be used to develop your own plant-specific checklist, whatever that may be. This is, I think these checklists are referred to Annex B of NFPA 70B. And so it's, like I said, it's intentionally designed to be general. And so we asked this question here because this is kind of some things to point out that should be part of your maintenance program. And so we kind of already discussed, like I said, what constitutes a qualified worker. How complete is your electrical safety program? And not just your electrical safety program, but your safety program in general. Now, smaller facilities, you'll probably have it in just a couple of binders in an office someplace. Larger facilities, you'll have a whole safety department. This is the whole purpose in life, to maintain this stuff. And of course, PPE. We talked a bit about PPE. That has to be on there because PPE is maintained like anything else. And so as a result, you should have a list of all the PPE and how it's being maintained. This includes things like if you expect the uniform that your technicians wear to be considered PPE. And so this is one of the reasons why we have like uniform contractors like Cintas and Aramark and that kind of stuff, because that's one of the things they do, is to make sure your uniform's adequately maintained to still constitute as PPE. And of course, check meters for quality. That can be a day-to-day thing for each one of your technicians. You can also have a meter shop for calibration, that kind of thing. One of the things that commonly gets overlooked is the updating of the drawings. A good maintenance program should have the ability to update the drawings as the equipment gets changed or added. And so, in a perfect world, and I say this because I know that there's a difference between perfect and reality, is though that you have up-to-date drawings at your disposal at any given time of the day, readily and available in case anything happens. And so that would be the goal as far as prints are concerned. Now, to develop a fuse schedule, now this more pertains to your overcurrent protection device, at least in my opinion, in that, for example, with your circuit breakers, be aware that your circuit breakers are often rated for how many times they can be tripped and or how many times they can be cycled on and off. So, like for example, if you have a facility with a lot of lights in the overhead, and how you turn on the lights every morning we come in is you just go closing all the circuit breaker in the panel, you need to make sure that those circuit breakers in that panel are rated to be turned on and off several hundred times over the lifespan of that breaker, because not all breakers are rated for that kind of performance. And that's what this checklist is referring to. And then, of course, looking into predictive maintenance technologies. And each one of these is a separate level of training: infrared analysis, vibration analysis, ultrasonic, oil, et cetera, so on. And of course, as it pertains specifically to you. And then, of course, walk through of your most important control circuits. And if you're dealing with production, you know, how the controls are working, it kind of gives you an idea, making sure all the sensors are working like they should. And as I mentioned before, preventative maintenance boils down to keeping things clean. And so a lot of times it's all it is. You're looking for that infrared sensor. Does it have any dust or gunk on it? Because if it does, it's not going to detect whatever it is it's supposed to detect as readily. And those are the kind of things that you're looking for. And of course, if you're in the Midwest, this is springtime, which means we have cottonwood problems in all of our condensing coils. So right now, you all should be checking your condensing coils regularly, because that's one of the things that'll sap the efficiency off your HVAC units. And so that's kind of what this is referring to as well. So your motor lubrication program. We talk about motors in the class. I break down. One of the things I like to do in any class that I have regarding anything related to motors is I walk through the process and how to size all the parts of a motor. Meaning that, like the size of the conductor, the size of the overcurrent protection device, the overloads associated with it, and of course the conductors that are being put to it. So that way that there's a baseline of what is correct. Because if you're roasting overloads at regular intervals, or you happen to be popping fuses, you know, more than a few times a year, then that's an indication that you have sizing issues associated with the motor. And so, you know, part of your motor lubrication program too is going to be part of doing that as well, because one of the most common causes of death on a motor is improper lubrication. And I choose my word carefully on that, improper, because like with bearings, one of the things that can kill bearings is by over lubricating the bearings. And so part of motor maintenance is understanding, okay, do these bearings need lubrication? Yes or no? And then of course, making sure you use the right kind. And even still, even grease guns are rated for how much grease per pump they put out and what the PSI is. For example, you'd want a higher PSI grease gun in the event that you want the grease to be injected deeper into wherever it is you're trying to lubricate. And so, as far as your lubrication program, this pertains not just to your motors, but also to anything else like your pumps, for example. And of course, your maintenance procedures, which I already talked about. And then, of course, I also talked about the walkthrough checklist. And then finally, whatever training that you have, identifying who's qualified, and even the level of training and experience that they have on this. And even some of your seasoned technicians. One of the things that is going on in the industry right now, of course, is we have a lot of the baby boomers leaving and a lot of the newer generation picking up the mantle as far as maintenance goes. And so a lot of the older technicians, they have to relay that knowledge to the younger generation. But there is a caveat with that, in that much technology has changed over the years. And so some people, you know, they're not maybe up on the technology, and as a result, there's some things that they're doing that are a bit obsolete, meaning that they are not, you know, just because they've been doing it for 30, 40, 50 years, doesn't necessarily relieve them of having to be kept up to date on the training. And so, like one of my favorite examples on this is with our understanding of electricity. Even the like arc flash analysis. Arc flash analysis is relatively new to the industry. And yes, for many, many years, the idea that arc flash was there has been common knowledge. But because that event happened so fast, the science behind it was just not being done, because we didn't have the technology to actually observe and measure what was going on during an arc flash. So even as late as 2008 is when the science has solidified enough to make this a significant part of existing code. I mean, things like a high-speed camera. How long have high-speed cameras been around? And so that's what's allowed scientists to actually view, you know, the arc flash occur. And so, like I said, that is an example of technology and our understanding of the science of electricity, that is, how it has evolved even just within the last 10 years. And so practice for electrical equipment maintenance, like I said, comes to NFPA 70B, and the part of this is also maintaining the components of your electrical maintenance. Now, one of the most prominent components of this is, of course, your policy regarding work on energized equipment. Now, I do understand that sometimes it may be necessary, but my personal opinion and what I recommend to every single one of my classes is that never work on energized equipment. And the reason for that is because electricity behaves in mysterious ways as it goes, and as a result, you're increasing the probability for a mishap to happen. Electricity is something to always respect and take it and take into consideration when dealing with any equipment that works on electricity, which for most of us, it's almost all of our equipment. And so one of the most important components, I think, of an electrical preventive maintenance program is the policy, which many companies already have, is to not work on energized equipment. And if you were to take my class, I'd be happy to tell you any situation that you give me, you say, well, we have to work on it while it's energized. I'll give you a safer way to do it. And so, and I try to even though the law states that when it's infeasible or if it will introduce additional hazards, there are ways still to establish an electrical safe work condition with those in mind. And so that's pretty much the big point I make in a lot of my classes. All right, so last part of this is troubleshooting. And so I built a lot of the programs associated with the troubleshooting with a lot of examples, with the intent of the examples to one, discuss the operation of the equipment based on limited knowledge. Because a lot of us as technicians, we have the expectation that if it's broke, go fix it. And whether we know anything about it or not is not generally a good excuse, because sometimes things happen and, you know, that technician's the only guy that's available. But the cool thing about it is, though, is like, especially for take my classes, I go into try to equip those guys with you can fix anything, because a lot of this stuff has the very same principles across the board on each piece of equipment. And these same principles can be applied across the board. Same principle applies in all this with how to troubleshoot. And so, as you can see up here, knowing your system and equipment. And so from a management point of view, one thing to take into consideration, especially if the technician is inexperienced with that specific equipment, is to give them the time to do the necessary research. I mean, speaking for myself, I've been a technician for over 20 years now, and when I've been in teaching this stuff, if I know nothing about the equipment, generally if I think I can fix it in 20 minutes, I'm going to tell you, give me 3 hours. Because I'll run across something that I didn't know before. But the advantage of that, though, is next time I come back to it in the future, I'm going to know a lot more about the equipment because I took the time on the onset to get to know my equipment. And of course, knowing the test equipment portion of it is understanding what test equipment you have available to you that will help you, not just your multimeter, but things like an oscilloscope, or, you know, if you have micrometers or micrometers, excuse me. Whether to use a megger, what are the tools you have available and the various ways you can use that. So one of the portions of the course that I teach is exactly that. What test equipment, like a megger, how the limitations of a multimeter. I have the ability, if someone wants to know how an oscilloscope works, I can teach on that. I also talk about micrometers, precision levels, those kind of things. And then, of course, going into following safe work practices. And really what I go to in this is to squash the idea that just because you're troubleshooting does not mean you have a get out of jail free card in reference to working on energized equipment. You still need to follow safe work practices, even though troubleshooting is one of those types that says, yeah, I can work on energized equipment if I'm troubleshooting. No, that's not your ultimate get out of jail free card. The hazard is still there. And so that's what this means by following safe work practices. And so one of the things I also talk about is understanding why safety is important. Now, I understand that's a bit, my view on this is a bit controversial, meaning that here's one of my analogies that I use, and I'll tell anybody who will listen to this. So I use what's called, it's based off Harlow's monkey experiment. So in this experiment, what you have is you have 5 monkeys in a room. In the middle of the room, you have a ladder. At the top of the ladder, you have a set of bananas. And so in the beginning, what ends up happening is all the monkeys start playing King of the Hill. Each one trying to fight amongst each other, try to get to the banana at the top of the ladder. Now, during this onset, what then happens is that then the experimenter will then spray water on all the monkeys to say, hey, no, you cannot go up there after the banana. And so after a while, behaviors establish that not to go after the banana because they'll get punished if they do. Then the experimenter then, one at a time, begins replacing the monkeys with a new one. Now the new monkey, the first thing the new monkey does is tries to go to the top of the ladder and go after it. Now the other monkeys that have been there a while beat that monkey up because they're saying, hey, if you do this, we're all going to get punished. And so this repeats until all 5 or number of monkeys gets replaced. Now at the end of this experiment, what ends up happening, and you can tell this based on the behavior of the monkeys, is the monkeys don't even realize that the ladder is even in the middle of the room. It's as benign to them as some random column in the middle of a room in any room that we ever go into. They don't even realize it's there. It's just some obstacle. And so this is what happens when you have a safety program that has too many things that are associated with it, and that the technicians or the workers don't understand the purpose of each and every safety practice that you have. It becomes benign, and they do it just because that's what everybody else is doing, but they don't know why that is a safety thing. They just do it because they were told to. And so one of the things that makes a safety program effective is understanding that each safety thing that you have in place has a purpose, and each one of those purposes is widely known across the board to each and every technician. And as a result, one of the things too a good safety program does is also understanding to resist against knee-jerk reactions. And so this is what how you can read the differences between a company that can go 10 years without a single mishap versus a company that has a mishap every 3 months, even though they both have safety programs that are equally robust on paper. And so the idea with safety, and a lot of the training, at least that I do, is to try to understand that every safety thing that you put in place has a reason for it. It is there to reduce a specific hazard for you. And this is part of that whole, when you implement those controls, this is that awareness and documentation of it. This is why we put it in writing, why we put it out there, is because we recognize, we as the company, or we as those who monitor safety, understand that this is a specific hazard. And so a lot of the training specifically that I do was with that kind of mentality in mind. And so companies that enjoy workers have an interest in keeping the workplace safe. I mean, there's both a financial side of that and also just a humane side of that. And not only that, any one of us has ever been involved in a mishap, I mean, they just generally suck across the board. And so if that should be reason enough, let alone all the other stuff that the financial stuff that gets us attached to it. And last thing, I don't like the idea of taking a company and saying, yeah, OSHA's going to come in and fine you if you're not doing this. No, it's more about along the lines that you're going to cost that guy or that gal, whoever's working on it, the money that they need to keep up with their family or whatnot. But then again, this is also me talking from my military point of view, because even when the various things that I led in the Navy, I never had anybody get hurt under my watch, but I've known other people in their units who have. And it has a huge effect, not just on the company, but also their lives. And so this in itself is one of the reasons why it's so important to take a very astute, I think this is the word I'm looking for here, position on safety. And so it's more than just the financial issues or the legal costs of it, but also the kind of cost that it has on the individual and even the morale of the workers that are there. And so, of course, we talk about a lot of companies. Everyone in the workplace has a duty and responsibility to do whatever they can to keep the working environment safe. And so a lot of the training that we do is to be able to identify, these are the examples of what it means to be safe. And so things that I talk about frequently, like the National Electrical Code states that you're not allowed to block the front of an electrical panel. Well, from a safety point of view, that should make sense, in that the purpose of having that electrical panel there, and the reason why we don't have it blocked is in case someone's going to be electrocuted, that we can secure the power to it. And that's what I mean by making sure that safety makes sense and that we understand why we have that as a safety issue. And so you can do your part in understanding the procedures the company wants you to follow. And like I said, this is from the point of view from the technician, but also understanding part of the things that keeps a good morale in the company as well is to have them on two things. The technician understands the company has their back to make sure that the company is saying, yes, we want you to be safe. We recognize that some of the things you do are dangerous. So we, the company, are going to make sure that everything that you do or that we have you do is as safe as possible. while at the same time informing you of the possible hazards. And so, and the purpose of that statement was to understand the various perspectives that we can change in the training, whether it be from the technician point of view or from a macro top looking down point of view. And so once again, everyone in the workplace has a duty and a responsibility to keep their coworkers safe. And so even like with our electrical safety course, we even put on there even non-qualified workers, because if you happen to be involved in the work, whether it be you're a safety person, your job is to observe the technician as they do the work, or you're a manager that requires you to do some type of regular QA type stuff, you still have to understand the hazards that are associated with and how bad they can be, what the likelihood is of that, and of course what available PPE that you have available to you. And so, and of course finding that balance between making sure you have enough to keep you safe and you're not doing overkill to the point to where that it totally impedes the efficiency of your work. And so some other safety rules that we have here, this is just in general. And so one, always listen and follow the instructions, but that's also dependent upon the person who wrote the instructions that they understood the safety involved with it. So one of my personal goals as an instructor is, like, I started out as a technician and I've studied engineering in school, got my degree in engineering, and there is that animosity that often exists between technicians and engineers. And one of my goals as the instructor is to break down those barriers and try to understand, get both sides to understand that the engineer and the technician are basically saying the same thing from different points of view. And of course, this applies to how those instructions are made and followed. Once again, of course, some simple ones: keep hands away from moving and rotating machinery. That's a pretty easy one. So, you know, that's one of the things too. You know, if you're like, a lot of the guys who make decisions, or you have salesmen that come in wearing, looking nice in their suit and ties, are the reasons why the technicians will tell them, hey, you can't be here. We don't want your clothes or your ties or anything else that you're wearing getting stuck in this. It's for your own personal safety. Likewise, the technicians, that goes back, no watches, rings, no necklaces, make sure they're wearing eye protection, make sure their hard hat fits, that kind of stuff. So do not use a machine if you have not been shown how to properly operate it. Safely, that is. And that makes perfect sense too. If you don't know how to operate it, ask somebody, or at the very least, read the instructions. And so always ensure a guard is in place if equipment is not locked out. Well, in general, if the equipment is supposed to be worked on anyway, the rules of thumb say to lock out and tag out. But as operators, many operators know that they have to guard the equipment if they're going to be walking away from the station, prevent operation of that shouldn't be there. Also, one of the things I teach in my classes too are the various types of hand tools. Now, when I teach this, I try to be careful, because the last thing I want to do is insult other people's intelligence, because most technicians know the way around a wrench. But at the same time, there are also specialty tools out there. Some small things, like for example, your voltage rated tools, electrically safe tools, should not be stored in a bag like the rest of your wrenches and pliers. They should have their own special case, mainly because those other tools will tear up those electrical safe tools, rendering them not safe for electrical use. Other things would include, like, how to use a torque wrench, for example, the correct way to do it, or how to use like fuse pullers over, say, channel locks, for example. Some of those things are pretty no-brainers, but you got to bring them up there to remind all of us. Even I need reminding us. So, yep, that's probably the better way to do it. So know where the emergency stop buttons are located. Now keep in mind, there's a difference between a stop button and an emergency stop. An emergency stop is designed to stop the entire machine, all sources of power. So when you hit that thing, it's going to do a hard shutdown. Now, understanding this from a technician point of view is understanding that when it hard shut down, you're probably going to have problems when you bring it back up. Some safety things to take them out is anything that stores energy now is just sitting there with its energy stored, like capacitors, or if you have any hydraulic system that's holding a load in place above your head, or something to that effect. Because when you may have to go into a process to render it into a safe, normal startup process. So yes, the emergency stop is supposed to be hit in the event of an emergency, but at the same time, take into account that when you turn it back on, it probably isn't going to behave like you think it will. And so once report any damage of any equipment that could cause an accident. Yes, there's this underlying fear that if I accidentally break something, or you happen to find out that it's broke, that you're going to get held responsible. And I don't know. My personal opinion on that whole thing is that I would rather have you tell me that you broke it or that it's broke and find it out that way than when someone else comes by and discovers that what it is, either because they got hurt or because they interrupted a process which that equipment was part of. And so that's really what you're weighing out this. And this is also a good point to point out a healthy work environment, in that to not create an environment where those who can report stuff don't do it out of fear. Because as far as good maintenance goes, many eyes are better than fewer eyes. And so if you have an environment that allows, no matter who sees it, hey, that doesn't quite look right, then at least what you can do is take someone who has the necessary training to go over there and evaluate it. Is this a good or a bad thing? And then, of course, always be patient and never rush through a job. And we could talk about this if you will, but this is one of those type of things that's like anything else. Slow and steady on a job. Especially the more hazardous it is where good maintenance planning comes into play. And sometimes this is why you would put in more stringent steps into a maintenance program, is to prevent the whole rushing of it, because it's important to take your time on it in order to alleviate any possible mistakes that will cause any major issues. And I stand by this because that's one of the things, like if you ever work in the nuclear industry, that's how it is. They're always about step by step, to make sure that you don't skip step or do a step out of the order, so that way we don't have a cascading problem. And so this is one of the reasons why the nuclear industry is still on record the best, as far as safety is concerned, the safest industry yet, is because this is the way that they approach all of their maintenance. And so also when troubleshooting. So troubleshooting, you must protect against 3 hazards when it comes to electricity. We talk about this. In this course, it's an abridged version of our already existing electrical safety course. And so we talk about the 3 hazards of shock, arc flash, and arc blast. And so we can't talk about electricity without bringing this up, because these hazards are always a possibility, especially when you're dealing with higher voltage applications, especially when you're dealing with 480 volts and up. And so these are things that the technicians need to be aware of. And so like in my class, whenever you come to any class I teach with a lot of electricity, one of my primary objectives is to make sure that my students understand the differences between voltage and current, and how those can manifest into the conditions of shock, arc flash, and arc blast. And so lastly, as I mentioned earlier, this is what many of the code books say as what constitutes a qualified person, has the necessary skills, knowledge, and safety training. And as a result, with all of our training, what you will see is this very pattern, is that we try to cater our training to fulfill this, to give our students the necessary skills, knowledge, and of course the applicable training. So any one of the trainings that you will come to in our classes will have just those in mind. And so who this pertains to, by the way, to kind of show you guys who it pertains to. Of course, you have your any of your equipment technician, your facility guys, your electrical guys, operators that deal with this, plants management, pretty much anyone that has to deal with the process that comes around where the hazards are associated. And so the various things that we talk about in a lot of our classes, as you can see here, we talk about motors, pumps, blowers, that type of thing, control systems, PLCs, VFDs, everything you can see, emergency generators. And then we have individual classes for each of these, but this course we talk about this stuff in general. And most of my exercises that I have are generic, common problems that you would see with these, and then of course how to approach it from a very systematic point of view. And so in our troubleshooting class, we talk a lot about the stages of this, and it's more about a mindset than it is anything else. So what it means to investigate the problem, and how important it is to develop a concise problem statement. And of course, creating a work environment that no idea is a bad idea. Don't shoot down the guy that may think that have like an idea that might be stupid, because you know what? Some of us, it could be something really dumb that why it caused it. Believe me, I've troubleshot enough stuff and you're like, oh, that's what that was. Oh, and you're kicking yourself because, hey, it was something so simple. And so, and of course, the analysis portion of it is bringing in multiple points of view. And one of the things I like to say, if if something is, you've been working on it for 2-3 days straight and you still can't figure out why it's broke, ask somebody that knows nothing about it. I used to say ask an 8-year-old, because that's back when my son was 8 years old. And so just ask him. And because someone who doesn't know anything about it will see something that's like, that is just, like I said, so simple that you would have normally missed because you're just so used to seeing it. And so that's kind of what the idea is here. You know, entertain multiple points of view. And then of course, implementation of this very idea. So yes, we can talk about ideas and how to troubleshoot things, but a lot of time, a good discussion in this also includes how we can implement these various things that we come up with, meaning that, okay, this is the problem, well, let's go through the process and how to fix it. So the last class that I had, for example, I had a lot of motorheads in my class. So we would talk about, one of the examples we talked about was belt maintenance. Well, depending on the type of car, depending on how you remove the belt. And so like one of the cars I had before, I had an old Cadillac once, and I had to get to the belt tensioner on that. Well, the plan was I had to remove the front end, the grill, and the radiator so I can have access to the belt tensioner. Well, that's part of the process. And so that's kind of the idea. So, and if you got to ask yourself, well, is this the best way to go? Now, one guy mentioned, well, you know, you could take off the splash guarding and wheel cover so you can get a side access to it. And so, and the idea behind this is to have that kind of discussion, bring in multiple levels of experience, and to create a plan. Meaning that use the planning portion instead of just what I call Easter egging, where you're just randomly replacing parts, hoping that you'll get it fixed with no plan in mind of how it's fixing it. And so I kind of got ahead here with this, with the whole troubleshooting as a team, kind of what I was talking about here. So hypothesize, come up with an idea. And so I like to think of myself as a scientific type thinker, is that in that no idea is a bad idea. Because if you come up with a quote unquote bad idea, all you're just is alleviating, that's not a possibility. Okay, it's not that, then let's move on. We understand how this is. But either way, if you don't hypothesize, you're going to be discarding it, ignoring it, disregarding it, forgetting it, neglecting it, as you can see up here. So, with that being said, we kind of bring it to the end of this. And so, as I mentioned before, this is a class that is based on general. The way I taught this class last week was it was a 4-day class. I had my original, it was divided in 2 parts, the maintenance section and the troubleshooting portion of it. I had a handful of students that did both the maintenance and the troubleshooting, and I had a handful of students that came in and joined later for the troubleshooting portion. And so those are the options available to you in the event of if you're interested in such things. So that being said, are there any questions for me at this point?
Yeah, feel free again to add any questions you have in the toolbar on the right-hand side, folks. And of course, as I mentioned earlier, the most popular question we tend to get is, getting a copy of the presentation. And again, just respond to the email that you'll get at the conclusion of the webinar, requesting a copy of the presentation, and I'll make sure I send that out to you. We'll also have it up on our YouTube channel as well. So if you or anybody else needs to take another look at this, you certainly will have the chance to do that. That'll be up on our website, up on our YouTube channel, probably by middle of next week. So if there are any questions, we'll give you a little bit of time here to write them in. I don't see any that have come through yet, though. While we wait for any questions, Kurt, do you just have any last minute bits of advice, or what should the next step be for folks if they want to get a little bit of a revamp on their maintenance and training programs?
The only thing I would have to say on this is to determine how effective a maintenance program is how often are you fixing stuff. A perfect maintenance program is one where you're never actually really fixing anything. If you're going to fix it, if you're fixing it, it's because you planned it. Now, like I said, there's a difference between reality and what actually happens, but the goal is to get to the point to where all your technicians are ever doing is inspecting and cleaning. And so if you want to know kind of how to measure your maintenance program, that's a decent litmus test. How often are you actually fixing stuff as opposed to just checking stuff? That's really all I have to say about that.
All right. No questions in yet, but just a heads up. The next 2 webinars we'll be having in June and July are going to be electrical safety focused. One is going to be on determining your risk of electrical safety problems. We're going to talk a lot about arc flash analysis. And then in July, we're going to talk more specifically about and almost exclusively about PPE. We do have a question that came in, Kurt, and it's just asking generally, where do you get a a maintenance schedule, or is that something that you can create on your own, or are there sort of some best practices or guidelines to follow?
That's a good question. In general, your maintenance schedule will be given to you by the specific piece of equipment. It will give you advice on what to do based on what that is. And so when you're referring to a maintenance schedule, it is as far as a general maintenance program is concerned, it is a compilation of multiple individual schedules associated with each individual piece of equipment. Now, if in the event that you don't have that information, say your equipment's too old or for whatever reason you lost it, yes, you can look up, like NFPA series are a great place to start, but there are other ones. Let me give you an example. Like, for example, you have a generator outside. That's one of the things NFPA 110 will do for you. It'll tell you how often that you need to do your maintenance test on that and what that includes. And so if you don't have what the manufacturer provided to you on that specific equipment, you can find out the guidelines from references like the NFPA series of what maintenance is needed. And so then you'll, from all your maintenance pieces, all your equipment, then you'll line up each one of your individual pieces and then say which one's, you know, weekly, monthly, quarterly, and then how you line that up and schedule it. That is the foundation of any maintenance program.
That actually dovetails nicely into the next question we got, Kurt. This person's asking if electrical maintenance standards are based on NETA, or do you go solely off of NFPA?
Very good question. So the NETA refers, if I remember correctly, the NETA, National Electrical, what's NETA stand for? I don't remember what that stands for off the top of my head. But anyway, if I remember this correctly, NETA primarily pertains to power distribution. If that's the same one I'm thinking of. Whereas was the other one NFPA is what he asked?
Well, yeah. Do you go off of NETA standards, or do we stick with mostly NFPA?
Oh, okay. So,
go off of that?
All right. So with NFPA, NFPA stands for National Fire Protection Association. Always, NFPA is generally made from the point of view of fire protection. And so with that in mind, a lot of this comes from the point of view of firefighters and preventing things from burning down. Whereas what you're referring to is more of the engineering standards associated with it, or also any type of how electricity works. Which one you use will depend on the application of it, or depend on what it is you're trying to accomplish. In general, I will say, though, that the rules are about the same. And the reason I say this is because regardless if you're talking about fire or for the perspective of electrical engineering, electricity is electricity. Current still causes heat and an electromagnetic field. Electromagnetic field still induces on other things that cause to be energized, which means we have had a good grounding, et cetera, and so on, and it just goes round and round. And so which one you use, I would say both. And which one is more applicable, it depends on what you're trying to use it for. In general, though, NFPA series is being more and more supported by law. And so keep that in mind, because National Electric Code is NFPA 70. And so I hope that answers your question.
Next question I'll actually handle, Kurt. The question is whether or not we use any simulations in our training. And the answer is not a simple yes or no. We do simulations as it relates to some of our hands-on courses where we do have some modules, like, for example, with electrical troubleshooting, where you can actually use a small portable module that will help you understand electrical troubleshooting basics. However, the future of training does relate very strongly to the use of AR and VR technology. And while that is not something that we have currently, it is something that we, as a company, TPC Training, are looking at. There are some really, really neat augmented reality and virtual reality training tools that will allow a student to wear a headset and actually live in the classroom simulate working on, let's say, a boiler or a generator. And so that is the future of training, and it is something that we are looking to, but it is not quite here yet, but stay tuned because that's where the industry is going.
And let's
take a look.
To add to that, John, by the way, I know for a fact that we are in our offices, we are working right now behind the scenes of developing such things. And
Yep.
so we're in the development prototyping stage. In other words, testing the feasibility of it. We don't have yet as a deadline as far as how advanced that's going to be, but yes, we are working on towards that to making it that what you're discussing to be better and definitely more engaging.
Yep. All right. I think that's exhausted all of our questions, and we actually have reached our time limit. So, Kurt, any parting thoughts that you want to give?
Yeah, I didn't feel comfortable with how well I answered that NETA question, and I just wanted to add a little bit to that. And so NETA is to the electrical world like ASHRAE is to the HVAC world. And so NETA will establish the standards that's necessary for like I said, the engineering side of things. Now, of course, I'm adding this for the benefit of everyone here. And so this is kind of bringing, those standards are based on the limitations of the various pieces of equipment. Now, I will say, like I said, from a fire protection point of view, though, regardless of what those limitations are, most of the time the fire protection standards will exceed those. Let me give you an example, just so I'll send this home. Like in motors, for example, if you were to size wires based on the full load current of the electric motor, you're going, let's say I'm going to use off the top of my head, use a 25 horsepower motor. Typically on that one, when you size a conductor for that, you're going to get a 10 or an 8 gauge sizing on that for the wire. However, if you were to apply that, now to apply the safety for the National Electrical Code, you have to increase the size of that based on the size of the fuse, which means instead of having a 8 or a 10 gauge, now we need to have a 4 gauge wire on there instead. Despite what the math that NETA would say, hey, yeah, mathematically, and my experience in engineering is the same. The numbers say, yeah, I can get away with using a 10 or an 8 gauge wire. But the safety standards established by an entity like the NFPA will say, nope, we need to step this up a bit because based on their research, this is more safe. So I want to answer that question a little bit better.
All right. All right. Well, thank you again, everyone. We hope you have a good weekend and a good rest of your day, and we will see you in June for the next TPC training webinar. Take care.